In this video, we are going to see a unique method for finding the cross product of two vectors a and b. So a is defined as 2i plus 3j plus 4k, and b is defined as 5i plus j minus k. So the first thing you do is to write the unit vectors I, j, k twice, and under each part you write the coefficients of the unit vectors in each vector. So for the first vector a, I have 2, 3, 4, 2, 3, 4. Then for the second vector, I have 5, 1, minus 1, and 5, 1, minus 1. So the first thing I will do is to find my solution for the I vector. So I have to draw a diagonal line from left to right with respect to I. So I will have this line. Then I will do the same thing for the other I, that is from right to left. So I will have this diagonal. So I will then find my solution of the I vector. So it will just be the multiplication of the elements from left to right diagonal. So I will just have 3 times minus 1, which is minus 3. Then it will be minus the multiplication of the right to left diagonal, which is 4 times 1. So I will have minus 4. So I will move to the second unit vector, which is j. So I will maintain the sign. For the determinant method, you change the sign. So I'll do the same thing. I'll draw a diagonal from left to right with respect to j now. So I will have this, and then I will draw another diagonal with respect to j, but now from right to left. So I will have this. So I will just have my multiplication, 4 times 5, which is 20. Then minus, I will have 2 times minus 1, which is minus 2. Finally, I will have my k vector, and I will draw the diagonal again for the k. So it will just be this one. Then the other diagonal, I will just have from here to here. So I will just end up with 2 times 1, which is 2, minus, then I will have 3 times 5, which is 15. So my v, the cross product of the two vectors, will just be minus 3 minus 4. So I'll have minus 7i, then 20 plus 2. So I will have plus 22j. Then I will have my k. Then it will be 2 minus 15, which is minus 13k. So let us prove our solution using the determinant of this 3 by 3 matrix. So the determinant is found with the first row containing my unit vectors I, j, k, the second row containing the coefficient of the unit vectors in the first vector, which are 2, 3, and 4, and the third row is containing the coefficient of the second vector, 5, 1, and minus 1. So I just have to find the determinant, and for the determinant, I have to interchange the sign. So I will have positive, negative, and then positive. So for I, it is positive. I will have I have to cancel the corresponding row and the corresponding column. So I will be left with this element. So it will just be 3 times minus 1, which is minus 3. Then 4 times 1, so I will have minus 4. So now I have to interchange the sign because it is negative. So I will have minus j. Then I will cancel the corresponding row and the corresponding column. So I will be left with 2, 5, 4, minus 1. So I will have 2 times minus 1, which is minus 2. Then 4 times 5, which is minus 20. Then my last part is positive, so I will have plus k. Then I will cancel the corresponding row of k and the corresponding column of k. So I'll be left with this part. So it will just be 2 times 1, which is 2. Then 3 times 5, so I'll have minus 15. So my b will just be minus 7i. Then minus 2 minus 20 is minus 22. Then I have negative here, so it will be plus 22j. Then I have 2 minus 15, which is minus 13k. So you see it is the same as this one. Finally, you can use normal multiplication to find your cross product. So all you need to know is I cross I is equal to j cross j is equal to k cross k, and that is equal to 0. So I have a tip for you to remember the cross product of two different unit vectors. So you can draw a clockwise path. So I have my I have my j, and I have my k. So if I have I cross j in clockwise, it will be the next unit vector, so it will be k. Then if I have j cross k, it will be the next in the clockwise direction, so it will be j cross k, it will just be equal to I. And then k cross I in clockwise will be the next element, which is just j. So the reverse of the product is just the negative of the solution. So I will just have j cross I as minus k, then k cross j will just be minus I, and then I cross k will just be minus j. So I can start my multiplication. So I have my b. So 2 times 5 is just 10. I will have I cross I because it's just the same. Then I have 2 times 1 here, so it will just be plus 2. Then I have I cross j. Then for I, finally I have 2 times minus 1, so it will just be minus 2. Then I will have I cross k. Then I will start for j, so it will just be 3 times 5, so I will have plus 15. Then it is just j cross I. Then I have 3 times 1, which is just 3. Then it will be j cross j. Then finally I have 3 times minus 1, which is minus 3. So I will have j cross k. Then for the unit vector k, I will have 4 times 5, it will be 20, and it is just k cross I. Then I will have 4 times 1, it is just 4, and it is k cross j. Then I will have 4 times minus 1, minus 4, and it is k cross k. So I just have to substitute this cross product. So for the first one, it is just 0, so I will neglect this one. So the second one, I cross j, is just k, so I will have 2k. Then I cross k is just minus j, so I have minus 2 minus j, so it will just be plus 2j. Then I have j cross I is just minus k, so it will be minus 15k. Then j cross j is also 0, so I'll just neglect this one. Then j cross k is just I, so I'll have minus 3i. Then k cross I is just j, so I'll have plus 20j. Then I will have my k cross j is just minus, so I will have minus 4i. So my b will just be, I have minus 4 minus 3i, so I'll just have minus 7i. So in terms of j, I have 2, I have 20, so I have 22j. And then finally for k, I have 2 minus 15, which is just minus 13k. So you can see it is equal to the solution of the second method as well as for the first method. So you may be asked to find the angle between the vectors a and b. So in terms of cross product, the formula you can use is the magnitude of the vector, the cross product of a cross b is just the magnitude of a times the magnitude of b sine theta. So your sine theta will just be the magnitude of a cross B, and in the denominator I have the magnitude of A times the magnitude of B. So I have my A cross B here, which is just this V vector. So it means the magnitude of A cross B will just be square root of, I have minus 7 squared, then plus 22 squared, then I have plus minus 13 squared. So if you solve this, I will have square root of 702. Then for A, you just find the magnitude of the A vector. So it will just be square root of 2 squared plus 3 squared plus 4 squared. That will give me square root of 29. For the V vector, it's just the square root of 5 squared plus 1 squared plus minus 1 squared. So this one is just square root of 27. So substituting my terms, I will have sine theta will just be square root of 702 divided by square root of 29 times square root of 27. So if you solve this, I will end up with sine theta is just 0.9468. So my theta will just be sine inverse of 0.9468, and that will give me 71.22 degrees. So if you want a comprehensive explanation on how to use Gaussian elimination method to solve simultaneous equations, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.